Okay, I'm sorry I had to be gone today, guys, but it's worksheet 4.2.3, and it's the next logical progression after what we did on Friday. I'd like you to find this on your iPad and have it up and ready to go. I'd like to have your substitute today, Mr. Bartz, I believe, pause the video and let you have time to get your iPad out and get it in the right spot. Okay, so hopefully you're ready to go here. Find the missing sides in each triangle. I labeled this with A and this with B. And of course, this is trig. You're going to use trig to find these missing sides. This is a lot like what we did on Friday. So I'm going to say, let's start with A first. We'll figure that one out. So if I'm using the 60-degree angle, you have to ask yourself, should I use sine, cosine, or tangent? And in this case, I have the opposite and the hypotenuse. So that to me says use sine. So sine of 60 is equal to, and again, if you want to use those little helper monkeys, sine is opposite over hypotenuse. And the opposite side is A over the hypotenuse is 14. Now I'm going to erase that O and H there and just say sine of 60 is equal to A over 14. Now all I have to do is multiply both sides by 14. But you're a little smarter than you were the last time we ran into this question. Now you know how to find sine of 60. Let's find that next. Sine of 60 is some ratio. Well, this, of course, comes down to your old 30, 60, 90 triangle, which hopefully you've got memorized by now. 30, 60, 90. That's 1, that's 2, that's square root of 3. If I were you, I would definitely write down that one and the other classic, 1, 1, square root of 2. This is 45, this is 45, this is 90. Those two are going to keep coming up over and over and over. Okay, so if I need sine of 60, instead of just leaving it as sine of 60, I can calculate it by looking at this triangle right here. Sine of 60, sine is opposite over hypotenuse. From a 60-degree angle's perspective, sine is opposite over hypotenuse. Root 3 over 2. So I'm going to replace this with root 3 over 2 is equal to A over 14. And now I just need to get the A alone. So I multiply both sides by 14 times 14 here times 14 here. That cancels. And then I could just reduce this. 14 over 1 and the 2 there, those could turn into 7. So it's 7 root 3. Right, that's A. I know there's a lot of work to be shown, and there's really not a lot of space to do your work in. So I'm going to make your load a little lighter here and let you skip problems 2 and 4 and 6 wouldn't help that much. Let's skip 7. Let's skip 9. And again, you can do these if you'd like the extra practice, but I'm going to leave you just that much more workspace by cutting out a few. If you want to put white boxes over them and then be able to write on those, that'll give you even more workspace. Like you can sort of insert a post-it note over the top of those. So anyway, I'm going to encourage you to, you can handle all of these problems. We've done ones just like it until we get to these are the same, it's just that they're going to use that 45-45 triangle, the 1-1 square root of 2 triangle. On this side, they get a little trickier. It's not super hard, but you need to be told that these are meant to be triangles where we know that they're equilaterals. It says given BC equals 60, then find AC and AB. And of course, that's referring to over here, BC being 60. Okay, so basically it's just like the problem earlier, but you need to know if these are equilaterals, then of course that's going to make a big difference in how many angles, or how many degrees each of the angles is. So you can assume that these are equilateral triangles. And if they are equilateral triangles, then these angles are all 60. Here, here, and here. Of course, if you split that in half like that, then each of those separate little angles there would be 30. All right? right? And again, if it's an equilateral here, this is 60 and 60, and this is 60, but it can split in half into a 30. And when you do that, something cool happens. Watch what happens. This becomes a 30. This becomes a 30. Now, this red triangle here, do you get that that turns into a 30, 60, 90 triangle? Because this one's 90, this one's 60, this one's 30. And you know what those side ratios are, right? So if you know that's a 30, 60, 90 triangle, this is 30, this is 60, this is 90, this is 1, 2, and the square root of 3. Then you can set up a little proportion to figure it out, right? Of course, if this is an equilateral and this side B is the same as that side, okay? And so now, if I draw this triangle out and say, all right, this triangle right here, I'm going to make it green now. I'm going to kind of turn it up like this and say, this side's 21, and the hypotenuse of it is B. We can start to set up a proportion between the two triangles, okay? I maybe didn't need to draw that triangle for you. Some of you would probably saw which sides go together without that. But this 21 on the long straight side goes with the square root of 3. Just like the hypotenuse goes with the 2. So now you need to be able to make a proportion. And a proportion is a fraction statement that two things are equal. So here's my proportion. Again, little algebra stuff that you need to know. The 21 goes with the square root of 3, like, I started with this one, I went to that one. Like the B goes with the 2. To solve for B, then, all I have to do is solve that little equation. So again, I started by making my old friend the 30, 60, 90 triangle, and then realizing that I really had a 30, 60, 90 triangle built into this, and then comparing those two triangles, this one and this one, I was able to set up a proportion. This side is to this side, like that side is to that side. And when I've got this right here, I just have to get B alone. Hopefully you know you just multiply the 2 on both sides. There you go. That's an example how to do that kind of thing. All right. 17 is pretty much just like the ones that were up higher on the worksheet. I'm going to clear and go on. Let's look at number 19, because 19 and 20 are a totally different kind of problem. All right. If this is 120 this way, then do you get that I can create a reference triangle here? This line right here is just begging me to create the reference triangle that goes with it, which is like this. Okay. Now, that's truly a reference triangle. This is the angle I really care about, and if it's 120 around to this far, then the remaining part, the reference angle, is 60. The total has to add up to 180, of course. All right, so now I'm going to take this little triangle here and blow it up out here. I kind of like to do that to separate it from the busy drawing. Then we know this is 60 now. We know that's a 90 because we dropped the thing down to the x-axis, and that makes a nice right angle. And if that's 60 and that's 90, that has to be 30. And look, we got a 30, 60, 90 triangle again. Now here's where the real master stroke comes in to figure out what the final answer is. We're trying to find the coordinates of point C, which is that spot right there. I hope you get that to get to that spot right there, you need to start at the origin and you go over and then up. And that would be its location. The over and then the up. So if it had been a simple place like, negative 2, comma 3, you'd have negative 2, comma 3. Okay? But I don't know this distance right here. I don't know that distance. But I can figure them out. All right? Back to my exploded out triangle here. This distance right here along the bottom that goes with this distance right here, that's my x distance. This is my y distance. And this is my radius of a circle. So if that's the radius of the circle, it should be the same as this distance right here. And it tells me by saying 1, 0 that the radius of the circle is 1. And therefore, this side right here must be 1. So doesn't it just boil down to another one of those triangles where they've given you the angles, or at least one of the angles, didn't use the other one, and they've given us the length of one of the sides is 1, and we can figure out this side and figure out that side. Yep, it's exactly the same. So now I go over and make my old friend the 30, 60, 90 triangle. 1, 2, square root of 3, and then I can hopefully, you can, call these A and B. You can set it up, equation for A, based on the 60-degree angle. I can say, I have the opposite, and I have the hypotenuse, so it must be sine of 60 equals opposite is A over hypotenuse is 1. And now I just got to figure out sine of 60 by using my old friend, the 30, 60, 90 triangle. Okay, and then I'll have it because A divided by 1 is just A, so all I really need to know is what sine of 60 is. All right, one little step at a time. This problem started by me noticing that this was a triangle on the inside there, a reference triangle. Then the really key moment was noticing that this point was labeled, and therefore I knew how big the radius was, and therefore I knew how long this hypotenuse was. It was 1. Then I realized, it's just like all the other problems. I've got an angle, I've got a side, I can figure out A, figure out B. The missing side. All right, that's all I got for you for today. I think that should be enough help for you to be able to handle this worksheet. It's mostly review material. Have a great day.